Hey everyone, in AB Calculus it is Mr. Canfield. Today I have my computer open because I don't have my regular recording stuff with me. That's okay. This is actually a really good lesson for me to do on the PDF. So I am going to kind of read through the stuff that Stu talks about here, talk about some of the pitfalls and things to avoid, and then we're just going to do a bunch of problems. And I mean a bunch of problems. There are oodles and oodles and oodles of problems. Zoodles of problems. We did have some zoodles at dinner. Let's see. So, the one problem that comes up repeatedly on AP exams is sketching a possible graph of f of x given a graph of the derivative f prime of x. We're going to do a billion problems because they're so important. In these problems, we're always going to start with a graph of f prime, and our goal is going to go back to f of x. So we're going to have to separate this from what we traditionally understand about graphs. The thing that I see here is not a collection of y values. Normally, if a graph has the point 1, 2, I can think, oh yeah, so the graph has a point 1, 2. Instead, what we want to think about is, oh, when x is 1, the original graph of f has a slope of whatever this value is. It has a slope of 2. So it's going to completely change the way that we think about these things. And drawing with the mouse is going to be a little bit ugly, but I think for other reasons it'll be good that this is all here. So the first thing we're going to do is we're going to make a sine chart for f prime. Main thing to pay attention to, critical values or critical points. So any time where f prime is 0 or when f prime is undefined. And we'll see some of those examples in the problems below. So we also want to pay attention when is f prime greater than 0 and when is f prime less than 0. When is it negative and when is it positive? Then examining the sine chart, we can determine where f is going to be going up and going down, or increasing and decreasing. And we're also going to find relative mins and maxes. Now, relative mins and maxes, real quick, just to talk about that. Let's say I have a picture, and it looks like this. And like we can put an endpoint here and an endpoint here. This has absolute maxes and mins. We could call this the absolute max. But we would call this a relative max. We would call this a relative min. And then we would call this the absolute minimum. So hopefully that distinction helps a little bit. Let's see. Then we make a sine chart for f double prime. Oh, wait, I need to back up real quick. Finding the relative maximum and relative minimum, we're not going to be able to like nail down and know exactly what y value they are. It's more that we're going to know the x value where they happen. Okay, then we're going to make a sine chart for f double prime. We're going to do this by looking at the derivative of f prime. Remember, derivative of something is the slope of it. So we're going to be looking at f prime and just thinking about its slope, and that's going to tell us f double prime. So we're interested in finding out when the slope is positive, when the slope is negative, the slope of the derivative. This is going to be able to tell us something called concavity. Concave up looks like a cup, concave down looks like a frown. So we will go in there, and points of inflection, that's when f double prime equals 0. This is the kind of the shorthand way that we're going to talk about it. We can get into a more technical definition, but that covers the majority of what we need today. So, and this is just a sketch because we don't know the exact points that it passes through. So what we are going to do is just kind of, you know, he says it great here. I don't need to summarize this. To create the sketch, place the relative minima, that's just plural for minimum, low on your sketch, and relative maxima high on your sketch. It is then a matter of connecting the dots, paying attention to increasing, decreasing, and concavity. So it's more of an art than an exact science. at the level that we are, you can get a much more exact drawing with more technical calculus that we haven't learned yet. So, okay. So this is f prime of x. Let's do a sine chart. So, and I'm just going to do the sine chart down here on this actual graph. What are the values of f prime all along here? Well, they're all 2. So they're all positive, right? Wait, what's something where you have a positive slope of 2 the entire time? Well, hold on. What's f double prime? Why did I draw that line there? F double prime. All right. What's the slope of this that we see here? The slope is 0. So that means, I'm just going to draw a 0 and go the whole way. This has no what's called concavity. It doesn't look like a cup. It doesn't look like a frown. It is completely flat. Wait, slope of 2. Wait a minute. There's only one thing ever that has a slope of 2, and that's a line with slope 2. So I can go wherever I want. I'm going to start at 0, 0, and draw a line that has slope 2. There we go. So I could have started in a different location. You know, I could have ended up with a line over here or a line over here. The important thing is that I ended up with a line that has slope 2. We're going to see more important, like, then the rest of the examples will be much more nailed down, but still not as nailed down as you might want. So let's look at this one. So first we'll look at f prime, and let's look at the actual values of f prime. This is a very, very important value of f prime. What's the output value of f prime here? It's 0. What about to the right of that? All of these values of f prime, what are all of these? These are all positive. What about to the left over here? Oh, these are all negative. Wait, so what does that tell me about the graph then? If I have negative f prime, 0, and then positive f prime. Well, remember that f prime is the slope of the original f. So we've got negative slopes. We've got a flat space. Then we have positive slopes. So we know that somehow this is going to come down, be flat when x is 0, and then go back up. So I know I'm going to have some kind of relative minimum at x is 0, and I can put that anywhere I want when x is 0 because I don't know specifically where I'm starting. So I'm just going to go here because I feel like it. I could have gone here. I could have gone here. I chose here because I feel like it. F double prime now. So f double prime, I'm paying attention to the slope of what I see here because I'm paying attention to the derivative of what I see. Well, what's the slope of what I see? Oh, it's a consistent positive slope. Sorry, okay, so I just have a positive slope the whole time. And I just kind of subtly threw this in, but I'm going to repeat it again. A positive f double prime, that indicates we have something called concave up. So that means the whole thing's going to look like a big cup. So I need to have a negative slope coming in. It gets flat for a second, that's 0. And then a positive slope after, and it's supposed to be upward like a cup. Oh, there we go. If you're like, I don't know how I would draw that and not have it be concave up, don't worry. We might see examples like that. Like we'll get there. But yeah, that's how we used both of these at the same time. By the way, everybody, this is just if you think about this, what kind of graph gives us this? Like if this, let's say we use this exact graph, x squared minus 3, right? If I called that f was x squared minus 3, what would f prime be then? 2x. The minus 3 doesn't want it mattering. And you can see 2x is not exactly right here. Like maybe I should have made it a little bit wider or something like that, but I'm not looking to get that exact here. Hey, what's f double prime of this? 2. A consistent positive value of 2. Okay. Wait a minute. If this is f prime, so this again, I can use. Oh, do I have Twitch open? Oops. So what we can do here, if your family has Amazon Prime and you like things for free, oh my goodness, get Twitch Prime. You get free games every month. They're not always good, but free. Free is free. Okay, sorry. So what kind of shape gets us this? Well, if f prime, this is some kind of parabola, right? Like some kind of negative x squared graph. Well, then what would I take the derivative of to get an x squared graph, but an x cubed graph? We can expect that we're going to get some kind of, if you understand what a cubic graph looks like, that's what a normal cubic graph looks like. Well, it's negative, so it'll be upside down. We should expect something like that. So let's go do this. All right, so I'm going to use my sine chart again, and I don't have as much space down there this time, so I'm just going to start up here. So f prime. So again, I'm looking at the output values of f prime. What are all these? Again, don't say, oh, it's going up. No. These values here, these are all negative numbers. So we've got negative f primes until here it's 0. And then we have, then we have more negative f primes. Right? Because I'm looking at the y value of f prime. So if I go over to my possible f of x, I have a possible, or I have a flat point when x is 0. And again, I can pick anywhere I want. So I'm going to pick here because they're not giving me specifics. In the next problem, they give us a specific. So, okay, let's see. I'm supposed to have a negative slope. That means that f is going to be like going like down. So I can even say, okay, so f, I know f is going down, but then it's going down again. We should pay attention to the concavity now too. So let's go to f double prime and see what kind of cups and frowns we need to look at. So f double prime, what's the slope of f prime? Well, we got positive slopes here, right? So positive slope, positive slope, positive slope, positive slope, positive slope. I have a 0 slope here, and then after it's going down. So I have negative slope, negative slope, negative slope, negative slope. So here, concavity wise, I've got smiley faces, frowny faces. So I'm supposed to have a smiley face before it and a frowny face after it. Well, would you look at that? That's a reverse x cubed graph. So this is how we analyze a picture to get another picture. How am I doing on time? 15 minutes. Okay. Because I want to cut this up into 2 parts maybe. Yes, maybe we'll stop after this page for this part. Okay, so the huge difference, we've got a lot of stuff going on here, but more importantly, possible f of x passing through negative 4, 2. So we're going to start at negative 4, 2, and we are going to say it definitely passes through here. And we're going to have to build everything around this point. So let's start. Oh, good, they give us something good to go off of there. So f prime, right? This is my graph of f prime. So prior to 4, we've got negative values. At 4, f prime is a 0. Between negative 4 and negative 2, what are these values? These are positive values, right? They're above the x-axis. I don't know why I like to draw so many pluses and minuses. You really just do 1. At negative 2, we hit 0 again. And then, oh, it's negative all the way until we hit 4, where it's 0. And then the y values there are positive after it. So what we know is that our original f is going down, flat, up, flat, down, flat, up. So we got a nice little squiggle going on here. Now let's talk about F double prime to get our cupness, cup frownness. So, oh wait, let me just drop in my, let's see, at -4, we know we've got one critical point. At -2, we've got another critical point. You know what? No. I don't know enough yet. Hold on. I just know that I have this thing. So we'll all right. We'll come back to you. So F double prime. It's going up, 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 up. Stop. So at -3, F double prime is 0. Right? Because that's where the slope of this is flat. And before it, it's positive. When's the next time it's flat? Down here at 1. And what's the slope of our picture here between here and here? It's going down, right? So we got a negative slope there. And then from 1 to the end, we got positive slopes. And so this tells us our concavity, right? This tells us we got concave up looks like a cup, concave down looks like a frown, concave up looks like a cup. So we got smiley happy times, and then at -3, this is what's called an inflection point, where we change from happy to sad. So I know to the right of 4, all the way until we hit 2. So, well, wait, before -4, it says we have a negative slope. So we're going down, 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 and then we hit that. And then my slope says positive until I hit 2. So I'm going up, 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 except it's not like up, 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 like that, because it says that at -3, we change from happy to sad. All right, so see how it's like curving up and then curving down. And then at 2, we go bam. I got a maximum at 2. And then we're going to hit a minimum at 4. So I'm going to hit a minimum at 4, so I know I can go down. And hey, look, at 1, that's where we're changing from happy to sad. So I'm just going to put a little reminder for myself. Or wait, no, from sad to happy, right? So concave down, concave down, concave down, concave down. Mwah. I'm happy now. Woo! All right. So like, I don't know if my like concavity-ness, the exact curvature of it's good or not, but I do know that right around here is when I was supposed to switch from being sad to happy, and I kind of missed a little bit, but hopefully the explanation is making sense. And then after 4, we're going up and we're concave up, so we're happy going up. This is mind-bendingly difficult for some people the first few times they encounter it. So I think these charts can be very, very helpful. I'm going to try to explain this next one from complete scratch, just in case you've missed stuff. If you think you get it, I would say go and try this. Trust the charts when you draw your picture over here. And seriously, I go on Schoology, check your answers with me. Like, it's okay to see if you're doing things right. Don't expect your Y values all to match up perfectly, but your general shapes should match up. Okay, so E. I've got room down here. So the first thing that I'm going to do is remember that this is F prime that I see here. The output values that I see are slopes. So one of the key things for me to focus on is places where the slope is 0. Where the slope of F is 0. Remember, these Y values of 0 tell me the slope of F is 0. So at -5, I know I've got either, like, I could have a minimum, I could have a maximum. I mean, I could have, just a place where it flattens out for a second too. but I've got some kind of flatness at -5. So we've got some kind of flatness at -5, and then we've got some kind of flatness at 1. So I know I've got to pay attention to those. So let's see, what do I know about f prime? Oh, before -5, before that 0, what are the output values here? The output values before this are all negatives, right? So I have negative output values and a 0 output value. All these output values are positive. And remember, the output values that I'm seeing here, these are telling me the slope of the original graph. So I had negative output values, 0, positive output values. That means the slope was negative, 0, then positive. So I should expect a minimum at -5. So I'm going to put a dot down here for a minimum. We haven't talked about concavity yet, so I'm not sure if it's going to like hook in like that, or maybe it's going to like swoop in like that. We're not quite sure just yet. That's why I'm not drawing the whole curve yet. And then I'm going up, going up, going up until I hit 1, where we have a slope of 0 again. And then after this, all these output values here are positive. So wait a minute. It's going up, it's flat for a second, then it's going up again. That's not a minimum or a maximum then. What's going to happen is we're going to see it go up, stop for like get flat for just a moment at 1. So I'll just put it like here maybe. And then keep going up after that. Now let's talk about f double prime. So f double prime, the zeros of f double prime are the mins and maxes of this graph. So I see a max here. Slopes before it are positive. Between here and here, slopes are negative. Slope here is 0. After this, slopes are positive. So this, paying attention to the slope of f prime, is paying attention to the derivative of f prime, is paying attention to f double prime. So f double prime is positive, tells me happy face. F double prime is negative, tells me unhappy face. And then we got another happy face here. There's an analogy for concave up and down, or not an analogy, a way that concave up and down will always work. Concave up will always collect water in it, and concave down will always deflect water away from it. So it looks like I start out concave up, and I'm coming in concave up, I stop. Oh, and I'm still concave up until I hit -3. So concave up, concave up, concave up. And then from -3, oh, it looks like all the way till 1, we're concave down. And then after that, we are going up again, and we're concave up. All right, so kind of a weird looking graph. All right, last one for this video. And then next video, we're gonna get into some of the dicier, trickier ones. And if you're like, Mr. Canfield, these are already tricky, it's okay. It's okay. We'll talk about what you can do in the homework from these. So, all right, if I'm just paying attention to f prime, then my outputs for f prime are negative, 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 0. So at -1, we're at an f prime of 0. Before that, we're at negatives. After that, we're at positives. So far, nothing too kooky. Let's talk about f double prime. Well, before it, we are going up at -1. We're stopped for a second. I'm gonna throw a little question mark. Is it? Yeah, I guess the slope is 0, yeah. And then after that, it's positive. So let's analyze our sine charts here and figure out what the heck is going on. Well, So if I'm looking at just plain f, it's going down, it's flat for a second, then it's going up. What about concavity? It's happy, and then it's still happy. Okay. So I'll pick a y value. Doesn't well, it's going down then up, so this is gonna be a minimum value, right? So I'll pick a minimum value at -1. Let's pick -4 because it's not telling me where. This is just a possible f of x, and I'm going down, 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 happy, 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 happy. Stop. Okay, and then afterwards, up, 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 happy, happy, happy. Okay, cool. Wait, this looks like an x squared graph. Here's the thing, ladies and gentlemen. What do I take the derivative of to get an x cubed looking thing? I take the derivative of an x to the 4th looking thing. X to the 4th and x squared look pretty similar, so it wasn't actually surprising to me that I got a parabola-ish thing. So let's go down and look at the homework and see which exercises. All right. So it looks like all the way up until G, it's more of the same. And it looks like G to the end, we're going to start seeing some stranger things, which I'm guessing, yeah, same letter here. So in the homework, you should be able to try G to, or F, up to F, since we did up to F right now. And in the next video, I will cover G to the end. I hope this has been helpful, but seriously, reach out to me if you have any questions. I would love to help you. Yeah, that's it. Bye.